We're going to look at number 13 in section 2.7. It's to find the limit as x goes to infinity of the tangent inverse. This is the arctangent function of this expression. So the arctangent function's domain is all real numbers, and we can push this limit inside the such a continuous function, right? We can push it inside because the inverse tangent function is continuous on its domain. And so, and its domain again is all real numbers. So I can push this limit inside. Now, the question becomes, what's the limit as x goes to infinity of this rational expression? Well, I do that down here. Notice this is of the form infinity over infinity. So we have some work to do. And the work I'm going to do is, again, the highest degree, the highest power of x in the denominator is just x to the first power. I'm going to divide top and bottom by x and take that limit. So 1 divided by x, root 3x divided by x is root 3. 3 divided by x, and x divided by x is 1. Now, as x goes to infinity, 1 over x is going to 0, and 3 divided by x is going to 0. And so I'm left with 0 minus root 3 over 1, or negative root 3. And so the tangent inverse of this limit is the tangent inverse of negative root 3. Now, how do you find this value? We want the exact value. Well, I'm going to skip over the answer here and go down here for a second to recall that the range of the inverse tangent function is values between negative pi over 2 and pi over 2. So first of all, your answer cannot be outside this range. If y is the tangent inverse of x, two things have to be true. Number one, tangent of y is x, and the value of y, remember, is between negative pi over 2 and pi over 2. So we're looking for tangent inverse of negative root 3. So tangent of y is negative root 3, and the value of y is between these values. So where is the tangent of y equal to negative root 3? Well, you do have the trig help sheet available. And so we realize we have the unit circle. We know tangent sine divided by cosine. We know each ordered pair is the cosine of the angle, and the y-coordinate is the sine. So first of all, to get a negative value for tangent, the sine and cosine have to be opposite signs. That only occurs in the second and the fourth quadrants. And when is that ratio, sine divided by cosine, equal to negative root 3? Remember, sine is the y-coordinate, cosine is the x-coordinate. If I divide root 3 over 2 by negative 1/2, I get negative root 3. So it occurs here. It also occurs down here, right? Negative root 3 over 2 divided by positive 1/2 is also negative root 3. So could the answer be 2 pi over 3? Or could the answer be 5 pi over 3? Answer, no. Because again, the value for y, as we said, has to be between negative pi over 2 and pi over 2, right? And both of those values, 2 pi over 3 and 5 pi over 3, are more than pi over 2. So when we talk about the arctangent function, we're getting values in either the first or the fourth quadrant. The first quadrant values are going to be 0, pi over 6, pi over 4, pi over 3, pi over 2, all those type values, right? Anywhere between 0 and pi over 2. Well, we don't get pi over 2 because division by 0, right? Sine divided by 0 would be undefined. So anything from 0 up to, but not including pi over 2. But what about the values down here? Well, now we're going to do negative angles. So remember how that works. This will be negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. And so the value of arctangent is going to be between negative pi over 2 and positive pi over 2. So the only value, the only location where the arctangent is negative root 3 is here, and that occurs not at 5 pi over 3, but what? Negative pi over 3. So negative pi over 3 is indeed the answer. So you do have to remember a little bit about your inverse trig functions, in particular, know about inverse sine, inverse tangent, and inverse cosine. Those are the most important ones. Okay, hope this helps. If you have questions about this, please let me know.